Okay, so in this video we're going to do complex fractions, and we're going to strictly do method 1, which is the keep, flip, change method. So we're going to get a single fraction on top, a single fraction on bottom, and then multiply by the reciprocal. So let's look at our first example here. So we can already see that we have a single fraction on the bottom. So I'm going to go ahead and rewrite that, because that means I don't have to touch it. It's already a single fraction. Now I am going to have to get the numerator into a single fraction, so I have a 3 and an x, which means that my common denominator would be 3x. So this fraction needs an x, and this fraction needs a 3. Now it's very important that you take the time to write that on numerator and denominator, because if you don't, you're just going to multiply with the denominator and you're not going to have the right answer. Okay, so that's going to give me x squared over 3x minus 9 over 3x. So now that they have the same denominator, I'm going to write them as a single term. So I have x squared minus 9 over 3x all over x minus 3 over x. Now from here, when I divide by a fraction, so I have a single fraction over a single fraction, and when I divide by a single fraction, I multiply by the reciprocal. So I have x squared minus 9 over 3x times x minus 3. I didn't flip it. Sorry, x minus 3 x over x minus 3. So I need to factor. So from here you can go ahead and opt to mark out those x's, because anything over itself is 1. X squared minus 9 is the difference of two squares, x minus 3, x plus 3, over 3 times x minus 3. Don't forget your 3. Now from here, my x minus 3's cancel out and leave me with x plus 3 over 3 as my final answer. Okay? So here we have an issue in that we do not have a single fraction in top or bottom. So we're going to have to make that so. So we have a 4 and a 4v. So this one just needs a v, and they will have the same denominator. So I have v over 4v plus 1 over 4v. In the bottom, so they're completely different, nothing the same. So both of these had a 4 where these don't. So this one needs a 4 and this one needs a v. So I have 4 over 4v plus v over 4v. So now that they have the same denominator, I can write this as a single term. So I have v plus 1 over 4v over 4 plus v over 4v. Now I have that single fraction over a single fraction, so I'm going to multiply by the reciprocal. So I have v plus 1 over 4v times 4v over 4 plus v. And again, those 4v's will cancel in the top, in the bottom, and leaves me with v plus 1 over 4 plus v. Okay? So this time we have a single fraction in the numerator, so I don't have to touch it. So I'm going to leave it just the way it is, but I have to get that single fraction in the denominator. So notice they have nothing in common, so I'm going to give the first fraction an x and the second fraction a 4. So I have x cubed over 4x minus 16 over 4x. So I have x squared over 4 all over x cubed minus 16 over 4x. So I have a single fraction over a single fraction. So I have x squared over 4 times the reciprocal, which is 4x over x cubed minus 16. So the 4's will cancel. 4 divided by 4 is 1. So I have x times x is x cubed over x cubed minus 16. Now, oftentimes students will want to simplify that x cubed, but remember that that is not what this is. We cannot bust apart a denominator. We cannot break that apart. So x cubed has to be divided by the quantity, x cubed minus 16. So this would in fact be our final answer. Okay? So again, we're kind of out of the monomials, so we have some binomials happening. However, the numerator is still that single fraction, so I have 5 q over q plus 1 over, remember anything over any whole number or binomial or variable can be written over 1. So that means that this one needs a q plus 1. Or you can equivalently know that q over q plus 1 over q plus 1, anything over itself is equal to 1 over q plus 1. So again, I'm not touching the numerator, haven't had to do anything with it. Now in the denominator, they have the same denominator now, so I can add and subtract like terms. So I have q minus q is 0, and then that leaves me with 1 over q plus 1. So I have a single fraction over a single fraction, so I can multiply by the reciprocal. So multiply by the reciprocal, q plus 1 over 1. So anything over itself is 1, so the q plus 1's go away, and just leave me with 5q over 1, which is just 5q. Okay? Okay, so again, we have no single fraction over single fraction, so I'm going to make that a 1. So this has a y, so this one needs a y, top and bottom. So that gives me 8 over y minus 4y over y all over. Same thing here, this one needs a y. So I have 12y over y minus 24 over y. So now that they have the same denominator, I can combine like terms. So I have 8 minus 4y over y all over 12y minus 24 over y. So I have that single fraction over a single fraction. So I can multiply by the reciprocal. So I have 8 minus 4y over y times y over 12y minus 24. Again, anything over itself goes to 1, so those y's immediately factor down to 1. I can see that I have a common factor of 4 here. Also, I'm going to take out a negative because remember, we're not used to seeing that variable second. So I'm going to take that negative out so that variable could come first and be positive. So I'm going to take out a negative 4 and make that y minus 2. You can always double check yourself, did I factor this out correctly? Because if you did, it should multiply back to be this. So negative 4 times y is negative 4y, and negative 4 times negative 2 is positive 8. I can also see that I have a factor, a GCF of 12 here, so I'm going to factor out 12, and I get y minus 2. So again, anything over itself goes to 1, and then 4 goes into 4 once, and into 12 3 times. So I have a negative 1/3 as my answer. Okay, last one, same process. I need a single fraction over a single fraction, so I've got to get those common denominators. So 4 and m have nothing in common, so I'm going to give the first one an m and the second one a 4. So that gives me m squared over 4m minus 4 over 4m. All over. So the least common multiple between 3 and 6 would be 6. So I'm going to know that I have to multiply this one by a 2, top and bottom. And this one has an m and this doesn't, so I'm going to multiply this one by m. So I have 2 over 6m plus m over 6m. So I need to write these as a single fraction, so they have a common denominator, so I can do m squared minus 4 over 4m. All over 2 plus m over 6m. Now I have that single fraction over a single fraction, which means I can multiply by the reciprocal. So I have m squared minus 4 over 4m times 6m over 2 plus m. And again, anything over itself divides to be 1. Now you can take a 2 out here of the 4 and the 6, but we can do that in the next step as well. So I can write this as 6 times m squared minus 4 is a difference of 2 squares, so m plus 2, m minus 2, all over 4 times 2 plus m. So because addition is commutative, I know that these two are going to cancel out. You can put in your calculator 6 over 4, math enter, or you can divide them both by 2, and you get that this is 3 over 2. So I get a final answer of 3 times m minus 2 all over